Welcome. In this video, we're going to go to a basketball game, and it's going to be the math basketball team playing. So they can't hit a three-point shot for the life of them. They can only sink foul shots and layups worth 1 or 2 points, respectively. So we're going to let A sub n denote the number of ways a team can score n points. So it's like you show up to the game and all of the different ways that your team can score 10 points, or all of the different ways that your team can score 100 points. And we're going to consider a different order, a different game. So if you score 1 and then 2, it's going to be different from 2 and then 1. Or it doesn't have to be a mix of, just 1, 2, 1, 2, 1, 2. You could say, well, if we're scoring 10 points this game, it could be all 1s. Or they could be all 2s. They could be all layups or all foul shots. So we're going to try to write down a recurrence relation here. We won't have to solve the recurrence relation. But as usual, when we're trying to find ourselves a recurrence relation, we will write down some small case scenarios to get an idea of what's going on. So we have an initial condition of a sub 0 that the question wants us to deal with. So a sub 0, if u scores 0 points the whole time, that would be one way that could occur. So we miss everything the entire game. So a sub 1, if we were trying to think of all the ways that we could score 1 point, that would be just making the single foul shot. So there would be one way to do that as well. So a sub 2, how many different ways could we get 2 points at the very end of the game? Well, you could make the 2 foul shots and you could have the 1 layup. So there's 2 different ways. Now a sub 3, if we think about all the different ways here, we could get all 1s again. We could get a layup and then a foul shot, or do it in the opposite order. So there would be 3 different ways. Let's keep going. A sub 4, let's try to count. So we'd have 4 1s as one possibility, or you could have a 2 and then 2 1s, or you could have 1 and then 2 and then another 1, or you could have a 1 1 2 or a 2 2. So there's 5 ways in total. So now once we hit a sub 5, maybe the counting is starting to get a little bit cumbersome at this point. Like, what if we count and we sort of miss some 1s and miss some 2s and we mix things up and we don't quite get the right number to go right here? So if we try to think recursively at this point, it's probably very helpful. There's really 2 possibilities here. Either you show up and your very first basket is the foul shot, or you show up to the game and your team's very first points of the game is a layup. It's either one or the other. So if it's a 1 that we start out with, let's think about looking back to the previous step. If we think of all of these possibilities, if we copy them all with a 1 in front, so I'm just going to write a 1, a 1, a 1, and a 1, and then copy everything below. So we have 4 1s, and then a 2 and a 1 1, 1 2, 1 1, 1 2, and 2 2. That creates 5 perfectly legitimate ways of scoring our 5 points. Now, of course, there's more ways. The other case that we want to look at is, what if our game starts with a 2? So if we start with a 2, then you could say, well, all of the different ways of finishing off this game are actually written above. If we take these possibilities and we pull them down here and we copy them, well, there's 3 of those possibilities. So let's just copy them all with a 2 in front. So 2 and then 3 1s, 2 and then a 2 1, and a 2 and then a 1 2. Now, because above we counted all of the possibilities, all of the ways of scoring 3, below we have all the ways of scoring 2 and then 3 afterwards. And we have all of the ways of scoring 1 and then 4 afterwards. So all of these ways here are all possible ways because we have gone through every single case. So there are 8 possibilities. So going forward, you could continue the counting in this way as opposed to just randomly, picking numbers out of the air and hoping that you get all the possibilities. So let's try to summarize what we just said. There are 2 cases. Let's write that down. In our first case, the game starts with a 1 pointer, with the foul shot. In the second case, the game's first point is worth 2, or the layup. So therefore, we can write down a recurrence relation. So a sub n is equal to these 2 cases put together. So in case 1, when the first point is worth 1, there are a sub n minus 1 ways to finish off the game. So if we think from above, looking back, when we score the 1 pointer first, if we look back 1 step to a sub 4. So in general, below, a sub n is equal to a sub n minus 1 in regards to case 1. But there's also case 2 to consider. So in case 2, the first point is worth 2. So when that first point is worth 2, we look back 2 steps to figure out how many different ways there are to finish off the game. So we would add the a sub 3 value of 3 to get that a sub 5 value below. And in general, we would say, okay, to get a sub n, we also need to add a sub n minus 2. Now, the 2 initial conditions that we need to start us off, to claim that this is a proper recurrence relation, a proper formula that does define a sequence, is a sub 1 and, of course, a sub 0 as well. They were both one way in both of those scenarios to play out the game. So our initial conditions are both 1. So this is our recurrence relation, is the RR for short, for recurrence relation. And you may recognize this particular sequence that we're building here. It's called the Fibonacci sequence. Many, many problems are solved with the Fibonacci sequence, and this is just one example. Thanks so much for listening, and we'll see you on the next one.